in 2012, we got a Japanese HapMap lymphoblasts, and where we found these insertion alleles having a high metabolic capacity to synthesize longer chain polyunsaturated fatty acids. So the deletion alleles, when we tested the deletion allele, part of it, the homozygous for the deletion alleles, the FADS expression, the enzymes which make the precursors to products, the expression levels of one of the enzymes, key enzymes, was lower. That made us to hypothesize that this insertion allele might have a high metabolic capacity to synthesize precursors to most physiologically important products. For example, arachidonic acid, EPA, and DHA. EPA and DHA are the omega-3 part of it, and arachidonic acid is the omega-6 part of it. So higher amounts of arachidonic acid can have a pro-inflammatory, pro-coagulation kind of a phenomenon, whereas EPA and DHA, they have more anti-inflammatory part of it. It was an in vitro study. So the hypothesis was like the insertion, a person who has 2 copies of the insertion allele might have a high chances if the omega-6 to omega-3 balance is not maintained well. If we have more omega-6s in the diet, less omega-3s, we hypothesized that these insertion allele individuals might have more pro-inflammatory kind of responses. So that led us to a clinical study by selecting a group of population from Pune, India, and a population from the US, largely from the Kansas cohorts.
So talk a bit about the importance of this balance of omega-3 and omega-6s.
Yeah, it's a good question. So traditionally, when we were evolved as a humans, the omega-6 to omega-3 balance was 1:1 ratio. So that's how we evolved as a human. Then what's happening after the rapid changes in our dietary patterns? Now the balance between omega-6s and omega-3 in our diets are changing rapidly. So now if we see in the US dietary patterns, we have 10 of omega-6s and one ratio of omega-3s. So the balance has shifted. Whereas in some of the developing countries, the balance has more dramatically shifted. For example, we mentioned in the paper, we cited one of the papers earlier published from India, showing that the ratio is between 20 to 30:1. That means omega-6s are 20 and omega-3s are 1. And for example, if we see omega-3 fatty acids, DHA is very important for brain development or retinal functions. And always this omega-3 EPA, the anti-inflammatory part, always competes with arachidonic acid, so which is the omega-6 part of it. So if there is a rapid unbalance between omega-3s and omega-6s, what we are doing is we are making more pro-inflammatory eicosanoids, which are made from the arachidonic acid, and thereby we are reducing the EPA part of it. That is causing more pro-inflammation and less anti-inflammation. So if we see the cancers or heart diseases, they are mainly because of the chronic inflammation. By 2010, this said, by 2010, 60% of the world heart diseases are in India. A hallmark of Indian society is like it's caste-based thing. And for many generations, for several generations, certain cohorts, they are eating only vegetarian diet, no meat in their diet. So what happened was, like, when we evolved, like, balance of omega-6 to omega-3, so if we change that oils, what we ate traditionally before, and now we are moving towards more omega-6 rich oils, what Tom has mentioned before, then there will be more of a pro-inflammatory kind of thing, whereas the omega-6 is more in the diet and omega-3 is less in the diet. That causes a lot of inflammatory responses. And for example, if these II individuals, what the favorable mutation, what we found in India, if that mutation has a higher metabolic capacity to make more longer chain PUFA, These are the individuals, if the omega-6s are more and omega-3 is less, because omega-3 and omega-6, they use the same enzymes to metabolize the precursors to products. So if there is more competition for omega-6 versus omega-3, then the competition favors omega-6 rather than omega-3. Then they make more arachidonic acid and less EPA and DHA. When we tested this allele frequency in India and US population is mostly of European descent. What we see there is the insertion allele in Indian population. When we did the statistics with Dr. Keenan's lab, they had the data from us as well as the 1000 Genomes Project. And what we have seen is that this insertion allele is 70% in Indian population, whereas it is only 18% in the US population. So 70% of the population, if they have the insertion alleles and if they have more omega-6 in their diet, they make more omega-6 products which are more pro-inflammatory. So there should be a balance between omega-6 and omega-3 in their diet to be healthier. We are moving towards precision nutrition or a precision kind of medicine. So for example, one size doesn't fit all. We have this vision to show that each individual we need to do by, for example, if we find this genetic polymorphism, where we can find like how to balance omega-6 versus omega-3s. It's a good starting point, and now we need to do the whole wild-wide population to see how the allele frequencies are, and then based on the allele frequencies, we might have an idea how to adjust the diets.